Stars don't just appear out of nowhere. They are born in special places in space called stellar nurseries. Enormous clouds of gas and dust where the conditions are just right. These nurseries are scattered throughout our galaxy, and others like it, hidden from view by thick layers of dust that block visible light. Inside, gravity quietly gathers material, starting a slow but powerful process that takes millions of years to create a new star. This process is not simple. It involves complex forces and delicate balances. Understanding how stars form helps us learn about everything from the light in the sky to the creation of planets and even life. In this documentary, we will explore the mysterious and fascinating journey from cosmic cloud to shining star. Stellar nurseries, or molecular clouds, are gigantic, cold clouds made mostly of hydrogen gas and tiny particles of dust. They are often hundreds of light-years across, yet incredibly thin compared to Earth's atmosphere. Despite this, they contain enough material to form thousands of stars. Their low temperature, sometimes just a few degrees above absolute zero, allows gas particles to stick together rather than spread out. The dust inside these clouds helps shield the gas from radiation outside, keeping it cold and dense. These nurseries are often found in spiral arms of galaxies, where gas and dust accumulate. Without these giant clouds, no stars would form, and the universe would be a much darker place. Inside these molecular clouds, tiny regions begin to collapse under the pull of their own gravity. This pull is weak at first, but grows stronger as more gas collects in one place. These denser areas, called cores, shrink and heat up as gravity pulls gas inward. Eventually, one core becomes dense and hot enough to form a protostar, the earliest stage of a star. This slow process can take hundreds of thousands to millions of years. Gravity is the main force driving this transformation from cold, diffuse gas to a glowing sphere of hot plasma. Without gravity, the clouds would remain scattered and stars would never be born. The gas in stellar nurseries isn't still. It moves in turbulent flows, swirling and mixing in chaotic ways. This turbulence can both help and hinder star formation. In some cases, it pushes gas together, creating dense clumps where gravity can take over. In others, it tears clouds apart, slowing the process. Magnetic fields also thread through these clouds, influencing the charged particles inside. These fields create pressure that resists collapse and can change the shape of the clouds. Together, turbulence and magnetic forces make the environment inside nurseries dynamic and unpredictable. Their combined effects determine where and how many stars will eventually form. Once a core collapses enough, it forms a protostar, a hot, dense object that will eventually become a star. The protostar is surrounded by a disk of gas and dust, which spins faster as the protostar grows. This disk is important because it can later form planets, moons, and asteroids. At the same time, the protostar often shoots out jets of gas from its poles, clearing nearby material. During this stage, the protostar is still hidden behind thick clouds and doesn't shine brightly like mature stars. Its energy comes mainly from gravity, as the gas continues to fall inward and heat up. This phase can last hundreds of thousands of years as the protostar prepares to ignite nuclear fusion. As the protostar's core temperature rises and reaches around 10 million degrees Celsius, hydrogen atoms start fusing into helium. This nuclear fusion releases enormous energy, pushing outward against the force of gravity. This balance creates a stable star that shines steadily for millions or billions of years. When fusion begins, the protostar officially becomes a main sequence star, entering the longest phase of its life. The energy from fusion powers light and heat and drives stellar winds that shape the surrounding space. This moment is the true birth of a star, marking the start of a new source of light in the universe. Stars come in many sizes, from tiny red dwarfs to huge blue giants. The amount of gas a star gathers during formation determines its mass. More massive stars burn hotter and faster, living shorter lives, sometimes only a few million years. Smaller stars burn fuel more slowly and can live for tens of billions of years or more. The mass also affects how a star influences its surroundings. Massive stars produce intense radiation and strong winds that can blow away gas in the nursery, stopping further star formation nearby. The diversity of star sizes creates a wide variety of star lifetimes, brightness levels, and effects on the galaxy. Massive stars don't just form quietly, they dramatically change their environment. Their strong ultraviolet radiation ionizes nearby gas, causing it to glow in bright colors and form H2 regions, clouds of charged hydrogen. These stars also emit powerful stellar winds that push gas and dust away. This process can both trigger and halt star formation. When gas is compressed by these forces, new stars may form nearby. But if the gas is blown away too much, star formation can stop altogether in that region. Massive stars live fast and die young, often exploding as supernovae, further influencing their nurseries and enriching space with heavier elements. Stars rarely form alone. Instead, they form in groups called star clusters. These clusters contain hundreds or thousands of stars that formed from the same cloud at roughly the same time. The stars share similar chemical compositions and ages. Over millions of years, some clusters remain bound by gravity, while others disperse into the galaxy. Studying star clusters helps astronomers understand how stars evolve and how planetary systems like our own might develop. These clusters provide valuable information about the history and future of star formation in galaxies. The story of star formation is truly the story of the universe itself. Every star born in a stellar nursery is a new light in the vast darkness of space, carrying within it the potential to create planets, and maybe even life. This cycle of birth, life, and death shapes everything around us, from the tiniest atoms to the largest galaxies. At Vision, we believe that understanding these cosmic beginnings connects us to the universe on a deeper level. As stars continue to form, die, and renew, they remind us that the universe is always changing, always evolving. Thank you for joining us on this journey through the stellar nurseries, where new worlds and possibilities come to life. Stay curious and keep looking up. Thanks for watching. If you've enjoyed this video, share your thoughts in the comments below, and don't forget to subscribe and like the video. If you think this wasn't a good video, you can also write down the bad points in the comments. Your constructive criticism can help us become the channel you want, delivering high-quality content that is not only captivating, but informative.